Okay, today we're going to look at, well, 1 second. Chapter 10, Topic 2, Permutations. If you recall from Friday, a permutation is just in the number of ways you can arrange a set of items. Okay, so like for instance, you got 5 set of items, 3, 4, 5. You have 5 choices for the first item, 4 for the next one, 3 for the next one, 2 for the next one, 1 for the last one. So the number of ways you could arrange 5 items is 5 factorial. We can generalize this to n number of items. So the number of ways you can arrange n items would be n factorial. Okay, so we don't need to write the events every time, the first event, second event, and determine the possibilities for or choices for each of those. We just need to know that permutation is an arrangement of items, and we can determine that by n factorial. So this first example, in how many ways can 6 trophies be arranged on a shelf? Well, we know that that would be 6 factorial. We're arranging 6 items, which is 720. Okay, you can either put 6 factorial in the calculator, or you can do 6 times 5 times 4 times 3 times 2 times 1. I would just put 6 factorial into the calculator. It will calculate it for you. And how many ways can 8 students line up? Well, we know that's 8 factorial. So we can put 8 factorial into the calculator. 8 factorial, 40,320. Now, sometimes you don't want to use all of the elements or all of the items. So for instance, some permutations do not use all the items available in a set. In this case, we use n permute r, where n is of course larger than or equal to r. And the formula for this would be n permute r is equal to n factorial divided by n minus r factorial. This is the number of ways n items of a set arranged r items at a time. Okay, so this would be if you don't want all of the items. So for example, 7 yachts enter a race, and how many ways can first, second, and third prizes be awarded? All right, well, the number of items we have is 7, but the number of items we want to arrange is just 3 of them, first, second, and third. So we can say that 7 permute 3, and then we can use this formula, 7 factorial over 7 minus 3 factorial, which is 7 factorial over 4 factorial. You can just put that in the calculator, or you can realize 7 factorial is 7 times 6 times 5 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. 4's cancel, 3's cancel, 2's cancel, 1's cancel. All that you're really left with is 7 times 6 times 5. It doesn't matter how you do this. So 7 factorial divided by 4 factorial is 210. So there's 210 ways to arrange the three of those elements out of the 7. Number 2, in how many ways can 4 skiers finish first place, second place, third place, and fourth place from a group of 12 skiers? Well, of course, the number of items I have to work with is 12, but the number of them that I want to arrange is 4. So I want to know how many ways are there to arrange 4 of them out of the 12. So that would mean I have 12 permute 4, which is 12 factorial over 12 minus 4 factorial, or 12 factorial over 8 factorial. Let's see what that is. 12 factorial divided by 8 factorial, 11,880. A lot of different ways. And then this example, in how many ways can president, vice president, and secretary be elected from a group of 20 people? So we have 20 people, 20 items here. We want to arrange them 3 at a time, vice president, president, and secretary. So we have 20 permute 3, which is 20 factorial over 20 minus 3 factorial. So 20 factorial over 17 factorial. Whoops. 20 factorial divided by 17 factorial equals 6,840. Okay, so that's essentially what we want to know. How do we arrange elements or items? How do we arrange them a certain number of items at a time? The order here is important. A group of 3, where president, vice president, and secretary, is not the same group of 3 if they have different titles. Okay, so the order is important in which you arrange them.